We know that electrons are negatively charged particles that are racing around outside the nucleus of an atom, that they're very, very small, but they move around in a lot of space. A couple of definitions you should already be familiar with. Energy levels are the general locations where electrons can be found. We can't know exactly where an electron is at any moment, but we do know that they live in energy levels, like different stories of a building. Also, valence electrons are the electrons on the outermost energy level of an atom. That's going to be really important here in a few minutes. There's a couple of tricks. The period number tells you the number of energy levels of every atom in that row. So, for example, hydrogen is in period 1. Okay? Hydrogen and helium both have 1 energy level. Period 2, lithium, beryllium, all the way over, they have 2 energy levels. Period 3 has 3 energy levels. Everything in period 4 has 4 energy levels, and so on. So that's the trick to knowing the number of energy levels of atoms in a row. Now, this is really going to be important when we talk about bonding, so make sure you listen carefully. The group number tells us the number of valence electrons for all the different atoms, the different elements in that column. We know that groups go up and down, and that there are 18 of them on the periodic table, as we see at the top here. So here's the secret. Every element in group 1 has 1 valence electron. Hydrogen, lithium, sodium, potassium, they all have 1. Everything in group 2 has 2 valence electrons. Now, the transition elements in the middle don't behave themselves. They can have 1, 2, 3, or 4 valence electrons. So we're going to skip the dip in the periodic table and pick up with group 13. Group 13, everything in group 13 has 3 valence electrons. We just pretend the 1 is not there in front of the 3. Everything in group 14 has 4. Everything in group 15 has 5. Everything in group 16 has 6. And everything in group 17 has 7. Group 18, the noble gases, are stable because they have a full outer energy level. Everything in group 18 has 8, except for helium. Helium has a valence of 2 because it only has 2 electrons. I'll show you why in just a second. Alright, so this is a nucleus of an atom in green. And we see the different energy levels. Each energy level has a certain number of electrons that it can hold. The first energy level can only hold 2. The second energy level can hold 8. The third holds 8, and the fourth holds 18. So memorize that pattern. 2, 8, 8, 18. 2, 8, 8, 18. Now, the reason that helium is a stable atom is because it only has 2 electrons, and both of them are in this first energy level, and it can only hold 2. It doesn't have all these other energy levels. It's not a big enough atom. So its outermost energy level is full, and that makes it stable. A full valence means a happy, stable atom. So atoms with a full valence will not bond with other atoms because they're stable. Okay? So that's it. We're going to do some more with this in class.